want to take some time to clarify the true meaning of work, what it means to do work, what it means to not do work, and also then power, which is associated highly with work. So, first of all, let's revisit the definition of work. So, work is defined as the ability to transfer or change energy levels. All right, so if I transfer energy to you, I'm changing the amount of energy you have. So some might say that work is equal to the change in energy within a system due to outside forces, outside objects, things like that. So in order to do this, in order to truly define this, I have a scenario for you where we have two identical twins and they're going to have a race. All right, so they're going to climb a mountain. All right, so here's my mountain. It's a gorgeous mountain. All right, twin one is going to climb the mountain. All right, he's climbing the mountain. Head, arms, I guess is a rope. So he's climbing the mountain, he's going straight up it, and then the other twin is saying, dude, that's insane. Let's just walk up the mountain. All right, and I will go to the top. And so one's just going to walk to the top, and one is going to climb to the top of the mountain. Well, if we have one climb the top of the mountain, well, let's say it's 100 meters. And then let's say the guy who walked, well, he had to go, let's just say 400 meters. So he had to go 4 times as far. Okay? Well, if you remember, work not only is the change in energy, but it's also force times distance. So some people might say, oh, well, hey, this guy is going to do more work because he had to go a greater distance. Some people are like, dude, I've tried to climb something. That is exhausting. That is way more work. Okay? So which it is? Well, let's figure that out. So fundamentally, if we want, we could do an LOL for each of these. All right, so I'll call you, let's go some colors here. I'll call you A and I'll call you B. So we could do an LOL for A, and we could say, well, initially, if you start off at the ground, let's call this, EG equals 0. Let's call that ground level. So initially you have nothing. And then at the top, you have obtained gravitational. And you're like, wow, how do I get something from nothing? Because energy has to be conserved. And so, well, you're doing work to yourself basically because you're doing chemical energy. So if you want, instead of none, you could have chemical energy, and then you could have less chemical energy and gravitational, but something like that. But fundamentally, your legs are doing work on your body, your muscles are doing that, and again, you can break your systems up as small as you want. And if I look at object B, all right, so we'll just go over your B blue. So if I look at B, well, fundamentally, you've got the exact same scenario where you start on the ground, so you have none. Again, work's coming from somewhere because you're going to end up with the exact same amount of gravitational energy. So if it's like, well, who did more work? Well, if they're twins, which I was very clear to make them twins, they have the exact same mass. They have gone up the same vertical height. So even though this guy traveled 400 at an angle, he still only made a vertical ascent of 100 meters, just like this guy did. So they both did the exact same amount of work. So person A and person B did equal work. Well, how is this possible? All right. Well, like I said, EG is based solely on your height. So the actual height they travel is the exact same. So they have the exact same mass. Well, they're both on Earth, so they have the same gravitational field strength acting on them, and they both traveled the same vertical height. All right? Well, they did the same amount of work then. They had the same changes in energy. But some people are like, man, walking does not make me want to pass out. I'm not exhausted after walking. I've tried to climb a hill. I've tried to climb a mountain, and that is completely draining. Well, one, you're using different muscle groups and other things like that. But here's what the thing is. If you look at this, other people traveled greater distance to do that. So there was different forces in this plane for that distance than were for here. Okay. My favorite analogy is you could have someone who took a boulder and they lifted it up over their head, and they did a lot of work. But you could also say, like, well, what if you lifted a feather? All right, so you lifted a feather. So a feather, or a leaf maybe. I don't know. It's a leaf. And you're just like, well, I lifted that up over my head. And then I had someone who carried 1 ton of bricks. The official symbol for 1 ton. All right, and they carried that for 2 miles horizontally. Well, the person who lifted up the feather actually changed the energy of that feather because they went up, so therefore they had a change in height, so they had a change in energy. But if the person carried that 1 ton of bricks and they carried it horizontally and they never changed their speed, so they've got the same speed the whole time, and they never raise it up or down, then therefore they never change their energy. So their change in energy is 0 because they just walked horizontally. So in order to do work, you must change the amount of energy an object has. So that's why you have to have an LOL diagram to really figure this out. Okay? And then if you look, say, well, this is where your basic, remember from a kid, they had the simple machines. So you had all your simple machines like, hey, how do we make this easier? Well, there's this ratio of force to distance. So if you have to walk up 4 times as far, well, it's going to be 1/4 the amount of force required to do that, because you're going to do the same amount of energy transfer, but you're going to do it with less force. So the trade-off is you have to do it over a much longer distance. So that's why it's like, oh, it's easy to walk up, but it's going to take you longer probably, blah, blah, blah. All right, so this is where the true definition of work and a true understanding of how you do work goes into play. All right, now the other thing that's associated with work is power. Okay, now power is the rate energy is transferred. All right. Well, energy transferring is just doing work. So if I want, it is the amount of work you do, what just happened? Work you do per unit time, and that is the equation for power. Okay. So now, because it's a little different, it has its own units, and those units are watts. So for example, when you turn on your light bulbs, if you've checked them, they're like 60 watt, 40 watt, 100 watt, whatever. It's so many watts. It's telling you the rate at which it is using up or wasting energy, literally. So if you have a 100 watt light bulb, well, it's using up energy at a much faster rate than a 40 watt light bulb. And if you pay attention, the 100 watt light bulb is much brighter. And since it's brighter, it's giving off energy at a much greater rate. Thus, it's brighter. The 40 watt light bulb is giving off energy at a much slower rate, so that's why it's dimmer. Okay, it's not as bright. So whenever you do these power problems, which you'll have to do power problems, yes, they're fundamentally simple in the fact that you're going to do all of this LOL stuff, and so you have to calculate the power done through figuring out how much energy was transferred, and then it's going to say like, oh, it took B. So you'll do all this math, and then you'll say, oh, B did it in 30 seconds, and A did it in, 180 seconds. So it's like, well, who was more powerful? Okay? And so then you could calculate how much work was done, because we know work is equal to, in this specific case here, is equal to EG. So I could do this calculation real fast. So power is equal to work per unit time. And in this case, my work is mgh, and the amount of time it took, pardon me, for one brother would be like 30 seconds. So you could say, oh, okay, so for person B, so the power of person B, well, that would equal to their mass. And I could be like, hey, they have a mass of 60 kilograms, 9.8. The height was 100 meters divided by 30 seconds. And so you'll do that, and might as well at least just get a number on the board here. 69.8 hundo divided by 30. And so you can say, hey, they have 1,960 joules, because this top one's in joules, because it's energy, per second. And that is the same as 1,960 watts. Okay, and then you could do the exact same equation, like, hey, person A. Well, if I did person A, they've got the exact same setup. So person A, well, they also did 60 times 9.8 times 100, except they did it in 180 seconds, right? That's the number I threw out there, 180 seconds, yeah. So they did it in 180 seconds. So I could figure out, oh, okay, how powerful were they? Well, do the math. And they are only, let's see, 326.67 watts. And so this is where you say, well, man, why was it so hard to climb the mountain vertically? Well, you're literally expending 3 times as much energy every second. All right? I think it's 6, my bad. 6 times as much energy every single second, versus the other person who's walking, and they're expending energy at a much slower rate. So therefore, your heart doesn't have to pump as fast, your muscle doesn't flex as hard, blah, blah, blah. So that's how power is. Power is, we often think of it as like an afterthought in terms of calculations, because you're going to have to do all the calculations you did before with energy and work, but then you're going to say, oh, and then divide by time, and there you get your power. So power is the rate at which energy is transferred. Work is your ability to transfer energy, and that's why they're linked. All right? And so remember, whenever we're talking about this, you only care about actually transferring energy levels. All right? So applying a force, well, its force of gravity is up and down, but you're moving left and right. Doesn't fully matter about this horizontal or stuff like that. All right? So hope that helped, and continue on with physics.